Today we are going to see R squared. So R square is very useful in terms of finding that is my input data is enough to predicting my output or not. So checking that the enough condition we can use R square. So after this video you will be see like easy to implementation of the R square, how we can use that and get hands on. So let's get started. So here if I explaining to you, here I just imported the few libraries which is required. Also I am just doing like model selection and splitting the data into training set and testing set. Then I am just printing the head which is showing me that I have 3 input feature and 1 output feature, sales. So TV, radio and newspaper is my input feature and sales is output feature. So let's see the shape of this data. So we can use df shape. I have 200 rows and 5 columns. So this column is useless because it's just incrementing the numbers, serial number. So now we can have like okay, head is we printed that. Now I just create the linear regression to just training my model. So I am training my model using one variable which is called radio, or we can say any one variable TV. I am choosing the TV here. After explanation or after this demo, I will show you like how R square work and why I choose TV only here, why I am not choosing the other variables. So after testing part we will implement or use the other variables as well. So I am just fitting the model. So I am just training my model based on my input feature and output feature. Now I am just predicting that. So test is my here and input feature is like same TV. So based on that it's predicting something. We have different method to find that the accuracy of the model or the checking that the is my data, how my data look like in the graphical way. We can use the matplotlib and all, but R square is also one of the tool which is useful for finding that okay, my input data is sufficient enough or not to finding my output variable. So for doing that, let's me import the R square first. So we can use the R square from the stat model as well, statistical model library, or the sklearn as well. But I prefer sklearn because many of the time sklearn is very handy to us. So that's why I prefer that. You can choose based on your understanding. So stat model is also there if you want to explore more or you don't like the sklearn then. So let me import sklearn, then matrix and import R2 square. So this is the method we can use, R2 square. So here let's initialize this with the help of, so as a passing of this, if I see here, you can see here y true and y prediction. This is the two parameter it take, and based on that it is saying that okay, is my actual prediction is close enough to my predicted one or not, and saying that okay, my data is not enough, that's why the actual prediction is not close enough to my predicted one. So here I'm just passing that. So you can pass like test of cells comma, you can pass y predict. Oh, sorry for that, I'm just adding some here. Now you can see that my R square score is 0.4. So let me explain how R score varies. So my R score ranges from 0 to 1. If my R score is near to 1, close to 1, then we can say I have like enough data to predict my output. If my R score is close to 0, then I have like not enough data to predict the output. And if my R score is like -1, sometimes there is the condition that R square will be the negative in the minus 5, -6, something like that. So if the value is negative, then you can see that it's a worst condition, means my data is not enough or not actually not related to my output variable, means my data is not helping to predict my output variable. So if we got the -5 minus variable or minus something, -4, -5, something like that. So here it's very important to get the range here. So see here my R score is like 0.4, which is means like my TV is somewhere predicting my sales or affecting my sales variable. So let me use here radio. So here I just retrain my model, retrain the prediction, retrain this and retrain this. Now you can see that with the help of radio, my R square is like 0.03. Means what is that means? My radio is not affecting my sales that much that the TV has, but my radio is little bit affecting my sales, not very much, only the few part of them. Okay, only the 0.3% is affecting my sales. So radio is also, we check that. So we can check that newspaper as well. So let me copy paste this. Okay, retrain my model, retrain the prediction, retrain this, and then we can see here the newspaper. So newspaper is also the affecting, but not that much to my area, but little bit on that prediction. So here you can see that. Okay, everything is good. So you can see that newspaper is affecting my sales, but not much as that like the TV has, but little bit. So let me run this all the cells from restarting the kernel, because I want to show you something different part. So here I'm just restart it. It's taking time. Now you can see that my newspaper is run successfully, and my newspaper is run successfully, and now it is showing that my 0.02%. So why it is showing that? Because here I am resample that data, and based on that data I am just predicting something. So here at the time, in the time of resampling, you will maybe say that okay, before that you are predicting like 0.02 and now you are predicting 0.02. So this happened because of it's sampling the data, and test data is little bit of 0.1 only, 0.1% only. So here I am just using the 0.2. Now it will give us the predict output. So why before that, why this is happening? Because of the overfitting comes into the picture. My data is overfit to my model, so that's why this thing is happening right now. So let me fix that. So let me rerun this. It will take some time. Okay, it's rerunning. Now you can see that okay, I again resample the data, and my prediction is something like the close to the 0.6, means like previous one. Now let me use the TV here, and let me run again all cells. So if I run that, then you can see here okay, my TV is 0.45. Now what I am doing is I am just adding one more variable here. Means I am checking that is my combination of TV and radio, how much the R square means my combination of TV and radio is enough to predict my sales or not, in terms of the good sales prediction. So let me run this, then let me run this and this. Now you can see that my R square increases drastically from 0.4 to directly 0.8. It is actually close to 1. So that means that my TV and radio is as much affecting my sales if it's combined both. Means I am selling the TV as well and radio as well, based on that sales is predicting. If I add here the newspaper, now I'm just reading, you can see that before that I have like, let me again, I have like 87 for the 3 of them. If I here 3 of them, I have prediction will be like something like this one, and I just use the TV and radio, then my prediction will be, you can see that 0.88. What is that means? Radio and TV. So I am just explaining you what is that means. That means if I add the newspaper in my data, the newspaper is not helping my sales that much that the TV and radio did, but it's okay to remove the newspaper from this prediction, because if you see the R square, right, so here 3 of them R square has like 0.87, but 2 of them only The r square is like 0.88, which means that my TV and radio is the actual parameter which is helping me to predict my output, not a newspaper. Newspaper is very, it's not in use actually. So it's we can't directly remove the newspaper. Newspaper can't didn't help me to predict my output in the terms of the output prediction. So in that way we can find that okay, these two variable is important and newspaper is not much important in terms of the predicting my sales. So this is the actually r square. Also r square has some limitations because sometimes you see, right, before that when we are using the newspaper, right, so at the time of using the newspaper, if I use here only newspaper, actually newspaper is not helping me to predict the output. But if I only pass the newspaper here, it will be giving me something value or something like that. You can see here some, because it's a, you can see it's not giving me the minus value, but before that it is giving me plus value as well. So it's giving me something value because it's a mathematical formula, right? So it has some number, so based on that number it's calculating that. So r square is, it can take any argument, and if the number of argument increases, r square help me to predict the output. But sometimes that's not a case, because some variables is not actually affecting my output. If I want to give you some example, is like my caste is not affecting my income of the salary of the employee, or salary of the employee, or caste of the employee is not affecting to the salary of the employee, which is not related to each other. So for that, because of that, actually r square is a limitation, has some limitation, because it's not like overcoming, or it's not capturing this feature, this non helping input variable. So that in terms of, so resolve this problem, we have the adjusted r square. So adjusted r square will help you to find the, like, what is the, like, help you to find the what is the actual variable and what variable is affecting my data, and based on that adjusted r square is calculated, and which is same like r square, but only difference is that r square has some limitation which can result in the adjusted r square. So for now adjusted r square is in research in place. So in the sklearn we don't have any function to calculate the adjusted r square, we just have to need to implement or use this mathematical formula to find that. So but most of the time we use the r square only, so which is pretty enough for finding that the relationship between the independent variable and dependent variable. So that's pretty much from the r square side. It's used many of the times. We can use other concept to do the same operation like we did here, but sometimes there is the condition that you should know the many tools, right, before you predicting or working on the actual data. So that's why I am just creating this variable, because this is the one of the tool which sometimes in some cases we can't use the graphs and mean square error and something like that. So at that time we can use r square to predict something, or checking that the what is the relationship between my dependent variable and independent variable. So yeah, that's pretty much from my side. Thank you so much.